Exercise 20. Let's show that the category set is not category equivalent to its opposite category set up. Okay. We prove by contradiction. I mean by absurd. Suppose we have a functor from f from set to its up and this functor gives isomorphism of categories, category equivalence, which means that it is fully faithful and essentially surjective. Then let's induce some contradiction. Recall that the empty set is the initial object in the category set, and the single point is terminal. Of course, up to isomorphism unique. Okay. So, particularly we will have, because this point, single point, is terminal, so we got homomorphism to category set from any object, so any set X, to a point. There is a unique map. So at the home set, this is a set of one point. So in the category of set, this is isomorphic to a single point. And then by the fact that f is fully faithful, this is also isomorphic to the home category set up fx and f acting on this single point. But what is this? By the relation between set up and set, or by definition of opposite category, this is just fx up. Sorry, this is just change the source and target. Not yet find contradiction, but then f is essentially surjective. Implied that recall definition for any object y set there exists object in the same category such that, sorry, basically when I say that y was set up, but it's the same as y set, okay, such that fx isomorphic to y as a set, with bijection. Particularly, this implies that home set from F, a single point, to any object Y, because this is isomorphic to some fx. And this is just, again, by fully faithfulness, just so. Should I write setup? Let me first write like this. It doesn't matter when you write F or something, it's in the category set or setup. It doesn't matter because the object is the same. The important thing is direction of the home. Okay. So fully faithful will tell you that this is isomorphic to, I would say, yeah, so just by what I've observed here, this is just isomorphic to single point. So here we'll have something rather restrictive, which tells that for any set, if you consider the home set from FO point to Y, it should be, there should be only one map of sets. And this is by the universal property of initial object. This is saying that FPT is the initial object. So up to isomorphism, of course, which means, but initial object is empty set. This any FO point should be empty set. And now, can we find some contradiction or give some counterexample? If we construct a set with two elements, the home set of point to X, the two choice. Because for any element in the domain, you must give a target. You must give it image either A or B. So it's bijective as a set to X itself. through the functor f if is full. This is the same as set up f point and fx. Again, this is okay. Firstly, f point is an empty set. We got this. Secondly, projection of home set, set up, and set. This is fx. But the set of a set to empty set is empty. Because for any element you must define what is image, and there's nothing to define, so there's empty. This is not empty. Notice this is not empty because x is not single point. So to define the map from non-empty set to empty set, there is only the empty set. This is a contradiction because our x at the beginning was not empty. Finally prove it's isomorphic to empty set. Here I also put a small x size of question. What is the home set from empty set to empty set? At least there should be identity is contained there at least.